Alrighty, what the crap is going on, YouTube? So we are back again today, and we are about to talk about casting and promotion with the primitive data types. So Java, like I was telling you, most of the time you're going to be using ints and doubles, and that's because Java has something called promotion, right? So what promotion is if you're trying to use a byte or short, it will automatically convert those into type int. And similarly, if you're trying to use a float or something, it'll convert it into type double. So to get around that, say we want a very specific thing, we have what's called casting. But to first show you the promotion, I'm going to show you what would end up happening if you didn't go about specifically telling Java what you were wanting those variables to be. So if we come in here, right, and we have short x is equal to 15,000, right? And then short y is equal to 10,000. Now, if you see, there's no errors right now. In fact, I can even print both of these out, right, without any issues. Build, and it comes out, and that's because 15,000 and 10,000 both already fit into the short pool. So you wouldn't think that anything's really a problem, but these are actually being upgraded into ints. And you can see that if you come down here and we were to go short z equals x plus y. And now you see we have an error. Even though 25,000 is within the short pool, if we go ahead and we try to run this, it's going to fail to compile on us, and it's going to throw us an error. So if you see right here, Java incompatible types, possibly lossy conversion from int to short. So these are being upgraded into the int, and then it's trying to restore them into a short, and a short is smaller than the int, can't store it, even if that number is technically within the short pool. So what we can do is we can cast this number, and that's telling Java, hey, the result right here, I want specifically to be a short, and then we can store it inside of the short. So what we do right here is we would put short in parentheses, and then parentheses around the expression that we want. And that's telling Java, hey, this right here is going to be short, almost like a multiplying by short if you want to look at it in a mathematical sense. You know, kind of like if you multiplied by -1 in math, it would turn everything negative. Well, think about it like this: you're multiplying it by short to turn everything short. So now if we run it, you're going to see that it comes out just fine. 15,000, 10,000, 25,000. All right? So try to remember that Java will auto-promote to ints and doubles. And then at the same time, when we look at longs, right, longs have a similar problem. So let's take this out. We'll leave the x and y because that's doing a good job for showing us what we are wanting to see. We'll come up here and we're going to change all of these to longs, right? Oop. If I can type. Okay, so now we have all longs. And you'll notice that we don't have to cast this for it to go ahead and print out. It's fine. So this suffers from a similar but slightly different problem. And that's because an int is smaller than a long, so the long has no problem storing it. But the issue comes in, we have we're trying to type out a long. Well, long can go way further than what is this? This is here's a useful tool, right? Whenever you're dealing with these bigger numbers, you can put underscores in, and they act like commas. So this is 15 million, right? Which is outside of the int pool. So even the long, it's trying to use that number and say that it's an int, even though we have the long expression at the very front. So what you can do is you can type L at the very end, and you can do lowercase or uppercase. I'm going to tell you right now to always do uppercase, because if you do lowercase, it might confuse you and you think that it's a 1. But always do uppercase, and that is similarly telling Java, hey, this is going to be a long. Okay, so now, even though we have the 15 million, it's no longer reading as an int, and this code will compile. All right, and you can see whenever I printed it out, you didn't see the underscores in it or anything like this. This is strictly much like comments. It's just so that it's easier for us to read. Or was that? That's not 15 million. That's 15 billion. My bad. Anyways, it's to make the numbers easier for you to read, especially when you get into longs and you're starting to see numbers like this. If you've ever played Diablo 3 or something and tried to read the damage numbers, that's pretty much what's going on. So, anyways, we can type that L after a shorter number like 15,000, though, right? 15,000, 10,000. Once again, we're back at 25,000. And that should go into an int because that's within the int pool. However, now we have an error if we change our solution back to int. And that's because we've already told Java, hey, this is a long. And much like the problem we had where the ints were causing the compilation error, trying to put it into a short. Well, now the long is causing the compilation error, trying to put it into an int, because a long is a bigger data type. If you really have to think about what's happening, is it's not too concerned about the number itself. What's concerned about is the memory that's having to be used, and since the long uses 8 bits and int uses 4, well, is what's causing the big error here. So whenever there's at least one long, right, even if we were to turn this back to an int, right, there's one long, so this will automatically be long. However, even though we put the literal right there, if we come down here and we cast this back into an int, it'll save the problem. You see how you can change how the data types and stuff are working throughout Java here. But it's something to be aware of, especially if you start getting into like floating number points with your floats and doubles. So everything, if there's one long, right, well, the long will convert everything below it into a long, right? So we've got long here, but if we've got a float, right, the float is actually going to convert everything up here into a floating number point, which is why we have an error here with the long. And then to further that, if we go with a double, I need to change this back to float. All right, we have the error again. So as you see the order of, I guess largeness, for lack of a better term, for these variable types, is byte, short, int, long, float, double. Right? Now you might be saying, well, honestly, I could just use doubles and ints and never have to worry about casting or anything like that. And honestly, you will pretty much just use ints and doubles. Very rarely will you have to use a long. You'll almost never have to use bike shorts and floats. But you might see it in other people's codes, and it's good to know how to read their code without going, what the crap is going on here? So there's that, and also casting will come into play later when we start talking about Java generics and array lists and linked lists and all this other stuff. And also if you're just trying to drop the end of a double. So if we go int z right here, right, and we'll go double x, double y, right? Well, we're going to try to just cast this back down to an int. But say it was 0.650 or 652, whatever. I'm terrible at typing sometimes. All right, and 789, right? But we don't really care about this. We just want it to the closest whole number, which you'll do quite often, actually. We will go ahead and run this, and you can see it's coming up with 652, 789. Well, that comes out to 25,001 and just drops off the decimal. So, anyways, that is casting and promotion. And next, we're going to be getting into operators and stuff. How to go ahead and do math in Java, because I know that's everybody's favorite subject. So, anyways, thanks for tuning in, and I will catch y'all in the next video.